Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll use derivative rules to differentiate these functions. So let's start with part A. So in part A, we are given h at x equals 2x plus 3 times x plus 4. So the first step here is to distribute the terms in these two parentheses, and for that we can use the FOIL method. So we'll multiply 2x by x, then 2x by 4, then 3x by x, and then 3 by 4. So we get 2x squared, and then 2x times 4, which is 8x, and then 3 times x, which is 3x, and then 3 times 4, which is equal to 12. So now we can combine like terms. So we get 2x squared, and the like terms are 8x and 3x, which is equal to 11x plus 12. So this is the simplified form of this given function h at x, and now we can differentiate this function. So we get prime of h at x equals, so the derivative of 2x squared over dx, and then the derivative of 11x over dx plus the derivative of 12 over dx. So basically we are using the sum rule of derivatives. So now we can find the derivative. So in the next step we can do, so prime of h at x equals, so in this term 2x squared we can use the constant product rule. So we can move the 2 out of the parentheses because 2 is just the coefficient of the term, and the derivative of x squared will be just 2x. So we get this by using the power rule. Plus, now here again we have to use the constant product rule. So we can move 11 to the front, and the derivative of x will just be 1. And now the derivative of 12 will be equal to 0 because 12 is a constant. So we get prime of h at x equals 4x plus 11. So this should be the final answer for part A. So now we can do part B. So in part B, we have to find the derivative of this polynomial function. So this is already in standard form. So we just have to use the sum and the difference rules to find the derivative. So prime of f at x will be equal to, so the derivative of the first term, which is 2x cubed, and then plus the derivative of 5x squared plus the derivative, oh sorry, this one is negative or minus the derivative of 4x, and then minus the derivative of 3.75. Now in the next term we can write down the derivative. So the prime of f at x, so here we can move the 2 to the front, and the derivative of x cubed will be 3x squared. So we have to use the power rule. And now for the next term, so 5 is the coefficient of the term, and the derivative of x squared will be 2x. And now in the third term, so 4 is the coefficient, and the derivative of x is 1. Now 3.7 is a constant, so the derivative of this term is 0. So now we can simplify the terms. So we get 6x squared plus 10x minus 4. So this should be the final answer for the derivative of part B. So now we can analyze part C. See, in part C, we are given another polynomial function, but this one is in factored form. So the first step is to distribute the t square into the parentheses. So we can rewrite the function as s equals, so t to the power 4 minus 2t cubed. Now we can find the derivative of this function, so we can use the Leibniz notation. So we can write ds over dt equals, so first we'll do the derivative of t to the power 4 over dt, then minus derivative of 2t cubed, the second term in this expression, over dt. So now we can simplify this expression. So ds over dt is equal to, so for t to the power 4 we can use the power rule, so we get 4t cubed, and then for the next term the 2 is the coefficient, so the derivative of t cubed is 3t squared, and now we can simplify the terms, so we get 4t cubed minus 6t squared. So this should be the final answer for the derivative of the function in part C. So now we can analyze part D. So I can use a different color, so it's easy to identify the steps. So we can start here. So for part D, so in part D we are given another polynomial function. So here we can use the Leibniz notation. So dy over dx, because the independent variable is x. So here we'll have to use the sum and the difference rules for derivatives. So for the first term we get the d over dx for 1 over 5 x to the power 5 plus d over dx, the derivative of 1 over 3 x cubed, then minus d over dx, the derivative of 1 over 2 x squared, and then plus d over dx, the derivative of 1. Now we can simplify this expression, so dy over dx. So in the first term 1 over 5 is the coefficient, and we'll use the power rule for x to the power 5, so the derivative will be 5 x to the power 4. So we move the exponent number to the coefficient level and subtract 1 from the exponent. Now for the second term, so 1 over 3 is the coefficient, and for x cubed we'll use the power rule, so we get 3x squared. And then for the third term, 1 over 2 is the coefficient, and for x squared we get 2x. Now the last term is a constant, so the derivative is equal to 0. Now we can simplify the terms, so we get dy over dx equals, now in the first term we have to multiply the coefficients 1 over 5 by 5, which is equal to 1. So the first term becomes just x to the power 4. Now in the second term we multiply 1 over 3 by 3, which is equal to just 1. So we get x squared. And then in the third term we multiply 1 over 2 by 2, which is just 1. So we get negative x. So this should be the final answer for derivative of the function in part D. So now we can analyze part E. So in part E we are given g at x equals 5, then x squared to the outer power 4. So the first step here is to combine these two exponents or powers, and we can do that by using the power on a power law of exponent. And using that law, we can multiply 2 and 4 in the exponent. So we get 5x and then exponent 8, because 2 times 4 is equal to 8. So now we can find the derivative. So here we can use the prime notation. So prime of g at x equals then derivative of 5x to the power 8. And now we can find the derivative. So 5 is the coefficient, and then for x to the power 8 we can use the power law. So we get 8 times x to the power 7, and we can simplify this as, so prime of g at x equals 40x to the power 7. So this should be the final answer for part E. So now we can analyze part F. So I can use a different color here. Now part F is a rational function. So the first step here is to simplify this expression by breaking up into two fractions. So the denominator of this expression is just a single term. So we can break it up as s at t equals, so t to the power 5 over 2t minus 3t squared over 2t. So now we can simplify these fractions as, so t to the power 5 over t can be reduced to t to the power 4 over 2, and then we get 3 over 2t, because t square over t can be reduced to just a single t. Now we can find the derivative of this function. So we can use the prime notation. So the prime of s at t is equal to the derivative over dt. So here the independent variable is t over 2 minus derivative 3 over 2t. Now we can start here. So the prime of s at t. So now we can move out 2 from the denominator as 1 over 2, and using the power rule, the derivative of t to the 4 is 4t cubed minus, so here we can move out 3 over 2 since it's a coefficient, and the derivative of t is just 1. So the final answer for the derivative of this function will be, so 1 over 2 times 4 is 2. So we get 2t cubed minus 3 over 2, just 3 over 2. Because 3 over 2 times 1 is just 3 over 2. So this is the derivative for the function given in part F. So these are the steps you have to keep in mind to find the derivative of these types of functions. So it's very important to keep in mind the steps that you need and the rules you can use to find these derivatives. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.